Alright, so now it's your turn to practice. How do we graph a system of linear inequalities? That's our essential question. Please understand that a system of inequalities is just two or more inequalities that you're graphing together. By the end of the week, we're going to be dealing with real-world problems, word problems. Okay?
No, please, no.
I know, but it's not as bad as you think. But there's some vocabulary that I want you to become familiar with between now and then. The inequalities, you're going to hear them referred to as constraints or limitations. Okay? But that's just the inequalities. The solution area, like we just shaded in, you're going to see that referred to as the feasible region. So just start to get comfortable with the vocabulary, feasible region. And the corners of the feasible region will be called vertices. So just keep that in mind. Okay, so here's a picture of what I just said. So just like we just did a minute ago when we graphed everything and we shaded the solution area, but just with this new vocabulary, each of these lines that we drew, those will be the constraints that we're talking about. The corners of the area that we're shading, those are called vertices, or one of them would be called a vertex. And that solution area that we shaded, that's the feasible region.
We write this down.
You don't need to write it down.
Big words.
Okay? Alright, so here's problem number one. If you're doing this at home, pause the video right now and try this on your own.
No.
Okay. So when you graph this one, let's start with this first equation. So we have y is greater than or equal to negative 3x minus 1. So the first thing you should have done is to graph these points. Starting at negative 1 and then going down 3 over 1, then make points to the left by going up 3 back 1. So you've got these points. Is this going to be a solid line or a dotted line, you guys?
Solid.
This one should be a solid line because of the or equal to part of it. Okay, so everyone should have a solid line. Now, am I going to shade above or below for this line? Above. I only heard like 3 people. Does everybody understand what is above? Okay, it's greater than is above. So everyone should have just put a little bit of shading on the above side of the line, this side of the line. Okay? So that's the first equation. Now we're going to move on to the second equation. Okay, so I'm going to start with my y-intercept of 3, and then I'm going to go up 1, right 1 from there because of the 1 over 1 slope. So here's my y-intercept of 3, and this is me going up 1, right 1. So everyone should have had all these dots at first. Is this one going to be dotted or solid?
Dotted.
Dotted because it doesn't have the or equal to part under it. Okay, so everyone should have had a dotted line this time. All right. Everybody think silently in your mind the word either above or below. Don't say it yet, because when you say it, I want to hear everybody. Everybody think the word above or below on this blue line. Ready? Say above or below.
Below.
Just once is enough, Abdullah. Everyone should have been saying below. Okay? This is a less than sign. We're going to shade below this time. Okay? So, what is the feasible region? Can everyone visualize where it is? Let's see. Let me get that vote going. So here we have zones 1, 2, 3, and 4. Show me on your fingers real quick which zone is the solution area. Show me on your fingers real fast, Scott. Show me on your fingers which zone is the right zone. Okay, put them down. Put them down.
I mean 0.
Almost everybody said zone 3.
Yeah, buddy.
Okay, and that is correct. Zone 3 is the zone that has all the little shades, satisfies both lines. All right, so that's how you did problem number 1. Any questions on that? Okay. Oh, by the way, this had one vertex. The vertex is right here at the corner where these two meet, and it should have been right at negative 1, 2. So make a note of that. Mark that on your graph, that the vertex is negative 1, 2. That's going to be important later in the week. Okay, so we have these three inequalities, and we need to graph them, just one at a time, okay? So when you look at this first little inequality, let's graph that first, okay? Remember, when you look at this one, in your mind you should be thinking x equals 3. X equals 3. Remember, when you have those tiny little equations like that, like x equals a number, does anybody know what those equations look like when they're small like that? All right, these are the ones that are either vertical or horizontal, depending on if it's x or y. And you might forget which one is which, but you know it's vertical or horizontal. The way you can remember which one is which is by doing what it says. If x equals 3, that means go to the x-axis at 3 and put a dot, okay? So this says x equals 3, so I'm going to go to the x-axis at 3 and put my first dot. Then I will just draw a line across that dot, not on the axis, but across it, okay? So if I do that, I'm going to wind up with a vertical line, okay? Is this going to be dotted or solid what I'm about to draw?
Solid.
Solid, because it's got the or equal to part to it. So if you did this wrong, fix it. But everyone should have put a vertical line at 3, like that. Okay? Let's do the next one. Okay, when you look at this inequality, you should be thinking, oh, wait, one more thing. The shading. As we go, I want to do a little bit of shading at a time. So please, do not shade in the entire half the page. Just put a tiny little bit of shading on it for now, Jordan, because I know you weren't here on Monday. When I look at this less than sign, this is the one time, when it's vertical, there's no above or below. Usually I do above and below. But this time I have to do left and right. Do you think I'm going to shade to the left or to the right?
To the middle.
Sure, point in the direction I'm going to shade with your hands. Okay? I'm going to shade to the left, that way. Okay? Now, wait. Yeah. Right, correct. It's backwards on my screen. But this symbol is almost forming an arrow. Okay? Showing me the direction I'm going to shade. So put just a little bit of shading on this side of the line. Just a little bit. Do not shade this whole space right now. Okay, now we'll switch over to the next one. Alright, this says y is less than 1, but I'm going to first graph the line y equals 1. Again, tiny little equation like this is either horizontal or vertical. If I forget which one it is, I do what it says. Y equals 1 means go to the y-axis at 1. So if I go to the y-axis at 1 and put my first dot, then I need to draw a line across that. So that's going to make a horizontal line. Is it going to be dotted or solid? Dotted, because it does not have the equal to line under it. So this will be dotted. So everyone should have a dotted line at 1. Am I going to shade above or below? Arriba o abajo? Above or below? I'm hearing different answers, okay? Look at this symbol right here. Does this symbol, is this a greater than sign or a less than sign? This is a less than sign, okay? Menos. If that's a less than sign, then I'm going to shade below, abajo, okay? Doesn't that make sense? Less should be lower. So I'm going to shade below this line. But again, for right now, I'm just going to do a little bit of shading. Just a bit. Okay, now the third line. Let's see, should I do green or purple?
Yellow.
Okay, green it is. So we start off with the positive 1, that y-intercept. So there's my y-intercept. But then I'm going to do the slope, which is negative 1 over 1. I always go to the right at first. So I'm going to go down 1, right 1 from here. So that's going to look like this. Okay, there will be a quiz tomorrow, so be ready for that. It'll just be just like this, just graphing and shading.
It's gonna be the easiest quiz in the world.
I hope so. Ojalá. Okay, now for this one, am I going to shade above or below? Wait, hold on. Let me yell at Brian. Brian, this is me yelling at you. Do you know what I'm yelling at you for?
Putting your head down.
I gotta spell it out. Please close up whatever textbook that is. Thank you. Did y'all say above or below? Above. Okay, this is a greater than or equal to sign. So that's going to be above. So above is going to be on this side of the line, up high. So just do a little bit of shading for now. Above. Oh, I forgot to make it solid. This is a solid. Why am I making this a solid line? Because it's got the or equal to part of it. Okay, and now I shade above, above. Okay, now here's the only time when I want you to do the full area shading. Now that we should be able to see the actual solution. Which part of this picture is the solution? Which one of these zones is it in? Is it in one of the outer zones or is it in the triangle? All right, this time it's inside the triangle. Not always. But the way that you know is look for the little shading that we did. The solution will be the space that has all the shading all around it. Johnny, I'm not seeing you looking up here, man. Okay? Look at the screen. I'm doing all this beautiful with the colors, and it's even a TV. You can't look at a TV for me, Johnny? It's a TV, for goodness sake. All right. So then we got to shade this. So you would shade this in. Okay, so that would be the solution area right there. And that's the only thing I want shaded in. I don't want to see the rest of this all shaded in, except for the little tiny bit of shading that we did before. Any questions on number 3?
Wait.
Okay, go ahead and do number 4. All right, anybody that wasn't sure about how to graph that first equation, please pay careful attention. Wow. When you get ready to graph this, start by thinking of the equation y equals x. Now notice, this is not like y equals 3 or something. This is not going to be a vertical line. This is not going to be a horizontal line because this is not just a number. This is x. If you got an x over there, this is going to be a diagonal line. So it's just a matter of how we're going to draw it. What's the y-intercept? You can't see the y-intercept, but it's there. Anybody can tell me what the y-intercept is? Say it. That's going to be the slope. This is like x plus what? Somebody said it. There's only one number I can add without changing anything, and that's 0. So this is like having x plus 0. This is my y-intercept. That means I put that first dot at 0 on the y-axis. Now, Scott was mentioning the slope to me, okay? That number that's in front of the x that we can't see. There's only one number that we can multiply by without erasing the whole problem. What number is that? 1. Okay, it's a multiplicative identity. So the slope is 1. And you can think of it as 1 over 1. Okay, so that should be a hint to you that we're going to start at 0 on the graph. And then we will go up 1, right 1. So we'll be diagonal from there. All right, see if you can do it from there with that hint.
What you going to do with 3?
Okay, so first we had to graph the line y is greater than 0. And like I said, this was going to be just like having, we're going to start off at 0 because the slope is 0, but then we're just going to go up 1 over 1 from there. So we're going to do like that. So this first line, these are the dots everybody should have had. Okay? Is this going to be dotted or solid? dotted because it does not have the equal to line under it. So this should be a dotted line. So everyone should have done like that. Now let's move on to the other one. When you look at this inequality that says y is greater than negative 3, you should be thinking y equals negative 3, right? Of course, that means go to the y-axis at negative 3. So your first dot should be right there. And then you're going to draw your line across it. So in this case, it's going to be a horizontal line. Is it going to be dotted or solid? Dotted. Dotted again, because again, it does not have the or equal to line under it. Okay? Oh, wait, I forgot the shading on the previous step. Go back to the first line. Because it's greater than, see how I put a small amount of shading above the line, on the upside of the line. You do the same. Okay? And then there's my second equation at negative 3. Okay, and I made it dotted. Am I going to shade above or below this time? I'm going to shade above. It's greater than, so I do a little bit of shading above the line, like I just did. Okay? Now, this last one, 0 is just a number. So don't get worried about the fact that it's 0. X equals 0. Again, it's one of these tiny little equations. It's going to be either horizontal or vertical. Okay? It's a little bit harder to know. The trick of just putting a dot and then drawing a line across doesn't help us remember. But x equals a number is always going to be a vertical line. So this one should be a vertical line. And it will be solid. Okay, so this gray line that I just drew is the bottom one. Okay, x equals a number is a vertical line. Am I going to shade to the left or to the right in this case?
Right.
To the left. Okay, remember when you have that vertical line, you can use a symbol like an arrow showing you which side of the line you're going to do. So we should have a little bit of shading on the left side of the line. Blam, like that. Okay? So can you see my little bit of shading on all the lines? Now, which one of these zones is the solution zone? Is it going to be zone 1, 2, 3, 4, 5, 6, or 7?
6.
2.
Yeah, everybody yell out what zone you think it is.
2.
Okay, most of you seem to understand, because most of you are correct. Zone 2 is going to be the solution area. Why? Because zone 2 is surrounded by the small amount of shading that we started with. Zone 2 has all of the shading pointing at it. So that's how you know zone 2 is the right area. Okay? So go ahead and completely shade in zone 2. If you didn't already do it. Okay, so it should be this space. Okay, so your graph should have looked very much like that. Any questions? Okay. Okay, here's problem number 5. Okay, please understand, this equation right here is like having x equals 0. X equals a number is going to be a vertical line. Alright, so this top equation is going to wind up being a vertical line. This one down here, y equals 0, is going to wind up being a horizontal line. Alright, I'll worry about that in a second. Here's the main thing, you guys. I'll come back to that later. Let's concentrate on properly getting this equation rewritten with y by itself. Okay, so you understand that we need to get y by itself. So we need to move the 4x. So let's subtract 4x from both sides. Please notice that this is a positive 24. When I rewrite it, it should stay a positive 24. I'm subtracting 4x, so that's going to be a negative 4x. So when I recopy this, so far I've got 3y is less than or equal to negative 4x plus 24. All right, Juan, are you with me so far?
Yes, I'm with
Okay. Now it's time to divide by 3. Okay? So if I divide by 3, I'm going to have to divide in all 3 of these places. Do I need to change the direction of this inequality? No, because I'm dividing by a positive. I don't change anything. So that means I have this. I have y is less than or equal to negative 4 over 3x, that just stays a fraction, plus what?
8.
Plus 8. So this is the equation I'm about to draw. Okay? So these are the 3 equations I'm dealing with. Understand this, you guys. The line x equals 0. That is a vertical line at 0. So this is the line x equals 0. Basically, the y-axis itself is the line x equals 0. Because this is greater than, I would put a little bit of shading to the right. So that first equation gives us this. All right, did you understand what I just did, Juan? Now, the y equals 0 equation, okay? Y equals a number is a horizontal line. It's sort of the opposite of what you might think. Because you know the y-axis goes like this, but y equals a number goes like this. They're opposites. So this blue line I'm about to draw, this is the line y equals 0. Okay, so I'm trying to match these colors for you. Again, this is greater than, so we should have a little bit of shading above the line. Okay, so that's what we have so far. Now we have this final equation. And we're just going to graph that. Let me switch to, let's switch to automatic. So there's our first equation. It was vertical line. A little bit of shading on the right. Our second equation, horizontal line. A little bit of shading above. Now our third equation should look like this. We have our y-intercept is positive 8, so that's up there at 8. The slope is negative 4 over 3. So I go down 4, right 3 from here. Down 4, right 3. Bam. Down 4, right 3. Okay? Any questions so far? Am I going to shade above or below this line? Below. Below, because it says less than. So I put a little bit of shading below the line. Is the answer going to be shaded inside or outside this triangle? Inside. Inside has all the shading that we started with. So to finish it off, we would go ahead and shade in the entire triangle. That's it. Did that make sense, Juan, brother? Okay. Any questions before we go on to number 6?
No.
Okay. All right. All right, let's try number 6. All right, number 6 is almost the same thing. You should be able to do it. Okay, my friends, as we look at number 6, please remember, all right, this is the line x equals 0. It's sort of the opposite of what you would think. X equals 0 turns out to be the y-axis. Okay? X equals 0 is a vertical line. It's at 0. It's the y-axis. This line y equals 0 turns out to be the x-axis. Okay, so just keep that in mind. All right? Anyway, the main thing is we need to rewrite this equation. X minus y is greater than or equal to negative 2. Watch this very carefully so you can see how we rewrote this. We need to get y by itself, so what's my first move? Subtract x from both sides. So your first step should be to go minus x like that. What do I have now?
Negative y is greater than or equal to minus 2.
Negative y is greater than or equal to negative x minus 2. Did I lose anybody so far?
No.
Brian, is this making sense to you?
Yeah.
What am I going to do now, Brian?
Divide by 1.
Divide by negative 1. Okay? This negative y is just like a negative 1, and I need to divide by it. What do I have to be careful of when I divide by a negative? We have to switch the signs. You got to reverse. We got to reverse that inequality. So this is going to go from being a greater than or equal to sign to being a less than or equal to sign. Okay? It's going to switch. So we're going to have this. We're going to have y is less than or equal to positive x plus 2. All the signs changed. So this is going to be the equation we actually wind up graphing. All right, don't forget, x equals 0 is actually the y-axis. Y equals 0 is actually the x-axis. Keep that in your mind as we go. Okay, I guess I'm just working all that out. All right, switching to automatic mode. Okay, like I told you, x equals 0, that's the y-axis. So that's a vertical line. See, because it's less than or equal to, I'm going to put a little bit of shading to the left. So please make sure you're putting your shading on the correct side of the line.
Can I go to the restroom?
Not in the middle of a problem. So let's put a little bit of shading on the left side of the line like I did. If you did it wrong, fix it. Remember that y equals 0 is a horizontal, is the x-axis. So that second equation is the x-axis. Because it's greater than, I'm going to put a small amount of shading above the line. Abdullah, take the hoodie off. So I'm going to put a small amount of shading above the line like that. Alex, head up. Now the third line, of course, is going to be like this. Start at 2 on the y-axis and then go up 1 over 1. So you're going to get this gray line. Am I going to put my small shading above or below this? Below, because it says less than or equal. Remember, we had to reverse the symbol. Okay? If you don't reverse the symbol, you'll shade the entire wrong area. But we will shade below. So the solution area, is it going to be inside the triangle or outside the triangle? What do you say, Tina? I didn't hear you. It's going to be inside the triangle this time, because inside the triangle is surrounded by the small amount of shading that we already did. Okay, so we know that the solution area is that small triangle. Okay, that's it. Any questions on number 6? Questions? Okay. So turn to the back of the paper. Yeah. Let's skip over 7 and 8 for right now. I don't want to confuse you with that right now. So where are we at?
It's fine. Should I put this on your desk over there?
Yes.
Yeah, it's great somehow. I'm putting on your desk. From him. Okay.
Okay, look, first things first. When you see this, that first equation that we had, see if I can go back. We had x plus y is less than or equal to 6. You had to get y by itself by subtracting x from both sides. So everybody should have done this, minus x, okay? So that would give us negative x plus 6 if we did that. Looking back at the second equation. Shh. Shh. Looking at the second equation, we have x minus y is less than or equal to 4. You need to subtract x from both sides. Be still. That's going to give us negative y is less than or equal to negative x plus 4. Then you need to divide everything by negative 1. That's going to give us y is greater than or equal to x minus 4. Okay, so these are the two equations that we've got. please remember that these two little equations down here are the x-axis and the y-axis. Okay? So these two little equations down here, that just puts us here in the first quadrant, because it's just greater than the x-axis and greater than the y-axis. Okay? This equation would be this diagonal line like that. This top equation would be this diagonal line like this. Can you see where the solution is going to be? The solution should be this area on the inside.